We are continuing our discussion, introducing some basic concepts of coding in Python. And just a reminder, we're working through Python workbooks, and you can find them at drstephpowers.github.io/BIA. And right now we are working on the appendix here, Intro to Python. So don't forget to go to that workbook. You'll need to sign into your Google Drive once you open in Collab. So open in Collab, sign into your Google Drive, save a copy so that you can both run the code and amend the code. So don't forget to copy to the drive. If you want to keep what you have changed, then don't forget also to hit save, because unlike other Google products, Google Collab does require you to save your work if you want to come back to it, as opposed to just the blank workbook that we're working through. So let's continue our discussion. And in this video, we're looking at the concept of Lambda. So Lambda in Python allows you to specify variables and fill in the values of those variables later. So we're essentially creating a formula, and we're specifying what are the variables in the formula, and then we can solve the formula, or we can do essentially linear algebra and create formulas from formulas and then solve those. So let me give you an example of what I mean. In economics, we like to look at equilibrium. Where is the size of the economy stable? Not growing, not shrinking. To figure this out, we look at the spending in the economy. We call it aggregate expenditures, and we compare that to the national income, how much people make in terms of wages, interest, money for land and other resources, and so on. So the economy is in equilibrium if our income is equal to our spending, because we make money, we then use that money to buy stuff, and then businesses use that money to make stuff, and we go round in circles. So we could use Lambda here to do linear algebra. So in economics, we have formulas for how much households spend. That's this first formula here, C, consumption spending. And we could create a formula for that. Let's say that it's 5 plus 0.6y. Y is a placeholder for the amount of income. So the more income households have, the more they're going to spend. Then we have a formula for I. This is investment spending. This is how much businesses spend. Businesses spend based on interest rates and their anticipation of the future, not based on current income levels. So there's no Y in that formula. Then we have government spending. The government spends based on policies, based on politics, and so it's not really dependent on the size of the economy. It's based on whether or not you want to stimulate the economy or fight inflation or pay off debt or whatever. And then we have a formula for what we call net exports. Net exports is the amount of money going out of the country when we export things like oil, compared to the amount of money coming, net exports is where money is coming into the country when we export things like oil versus when we bring in goods, and so we pay money to other countries. So we combine this household spending, this business spending, this government spending, and this trade to determine how much total spending there are buying goods and services in our society. So we get this formula, C plus I plus G plus XN. And that formula comes from adding up other formulas, so doing linear algebra. So we need to add the formula for C plus the formula for I plus the formula for G plus the formula for NX to get this aggregate expenditure formula. So Lambda allows us to specify that there is this variable Y, this unknown amount of income, and that we have a formula for C that contains Y. And then we have a formula for I. The variable is still Y, but you'll notice the variable isn't in the formula. Same thing for G. So when we look at here, we say C equals lambda Y. So lambda is what we're using as our function here. And Y is specifying what the variable is. And then colon, and then the formula for C, 5 plus 0.6 times Y. For I equals lambda and a Y, that's the variable, colon, and then the formula for I is 75. And we repeat this. Here's G, the variable is Y, but the formula is 160, doesn't contain a Y. Net exports equals lambda Y, colon 60 minus 0.1 times y. So y is in that formula. And then what we have here, which my face is covering up, so let's see if I can't uncover it with my face, is the actual formula for aggregate expenditures. It comes from adding up C and I and G and NX. And so notice here we have our Y, lambda variable, and we have our different functions. So let's look at how we would do this in Python and do our linear algebra. Okay, so let me just get out of here and go into our code. Okay, so same formula you saw before. We have C, I, G, N, and NX. And just notice here in the Python code, the variable is a lowercase y. And in the formulas, it's a lowercase y. That's going to matter because it has to match in terms of capital, non-capital. So here we have our formulas. C equals lambda y, I equals lambda y, G equals lambda y, NX equals lambda y, and then a colon, and then the formula for C, the formula for I, the formula for G, and the formula for NX. So let's load that into the system. And then what we want to do is linear algebra. So we want to find aggregate expenditures, which comes from adding up all these formulas, adding the formula for C plus the formula for I plus the formula for G plus the formula for NX. Notice these are all a function of a lowercase y. That's what the parentheses around y means. And then lambda y is the variable. So let's run that. So now what we can do is we can actually solve the aggregate expenditure function. If we give it a y, if we give it a level of income, then we can have it find total spending. So if collectively in this society, everyone's income adds up to 600, then we can do AE, parentheses, 600, and the national income, if national income is 600, so our income is 600, then total spending is 600. This is the point of equilibrium, where the amount of income is equal to the amount of spending. Notice that if we change this number so that national income is 400, the total spending is 500. If we make aggregate expenditures income 800, then aggregate expenditures are 700. So if collectively our income is 800, then we are collectively going to spend 700. So we didn't actually have to populate an aggregate expenditure formula to get this information. We had our formulas that were then added together into another formula, and then we could solve this one. Well, we might want to, for example, use this information to plot how much spending happens at different income levels. So not just typing in an income and then finding out the spending at that, but what if we want a range of incomes? So for example, our national income, our Y, could go from 0 to 100, 200, 300, all the way to 800. So at different income levels, how much is our spending? We're going to need some packages here. So we're going to use matplotlib.pyplot and call it PLT. This is going to allow us to plot graphs. And then we're going to import NumPy and call it NP. This is allowing us to manipulate the data to prep it. So we import the packages we need, and we're naming them something simpler just to make life a little easier. So we import those packages. And now we want to look at not just entering in a value here for the amount of aggregate expenditures based on a certain income level. Instead, we want to provide it a bunch of income levels. So national income can be all these numbers between 0 and 800. And in order for our graphing to work properly, we need to just convert it into an array. So this is just formatting so that it's entered properly. And the NP in front of it says it's using the NumPy package. So we're going to call the command array from the NumPy package and apply it to national income. Okay. So here we have an empty list that we'll call X. And then we're creating a loop here for I in national income. So it's going to go through each of these national income values. And for each one of those, it's going to take that. So first I is going to be equal to 0. It's going to put that in and it's going to find the aggregate expenditures. Then it's going to take I equals 100 and put that in and find the aggregate expenditures. And we're using the append function to populate this empty list with all the different spending levels at the different income levels. So we're combining a number of things we've been talking about in videos from our empty list we're going to look at in a video, we're going to look at some loops, and then also that appending to the list is what you see here. So it's going to go through this national income list, and for each item, it's going to find the aggregate expenditures, and it's populating that empty X to create a new list of the spending levels that go with those different income levels. And then we could take this information and we could plot it. So we're using that PLT, matplotlib.pyplot, we're calling PLT. And we use the command here from PLT called plot. And then whatever we want on the horizontal axis is what we call is the national income. That goes first on the horizontal. And then whatever you want on the vertical axis is what you put second. So here we want to plot national income on the horizontal. Our aggregate expenditures we're calling X will be on the vertical. And because we're looking for equilibrium, where the amount of spending is equal to the amount of income, we'll plot the points at which we get the same values. So we'll just put national income and we'll mark it. We'll have the x-axis, the horizontal, we'll label national income, and the vertical will label aggregate expenditures. To make it easy to see, we'll do a grid, and then we're telling it to show the plot. Now we'll go into more detail about graphing in later videos, but just to show you how you can use Lambda, what we've just created is a 45-degree line that shows where the economy is in equilibrium, where the amount of income is equal to the spending. And that's that 600 point that we found earlier. We also created a loop that shows us at each income level how much total spending there is in the economy. So as people's income goes up, we buy more stuff. But even if we all had no income, there's still basic necessities we need to survive, which is shown here. So we've actually used Lambda to do some linear algebra to add up these formulas together. And then what we can do is we can take that aggregate expenditure function, we can populate it by solving the formula with a particular value for y. And we created a loop to show all the different possible spending levels for the income levels. Okay. All right, so what about you? Can you do this? Can you use Lambda to help solve a problem? So let's use Lambda to create the formula. So this is the formula for the length of a triangle, right? You've heard of Pythagorean theorem, a squared plus b squared equals c squared. Let's find c, the length of one of the sides of the triangle, given a and b. So what is c if a is 2 and b is 3? Okay, let's try that one first, and then we'll try what if a is 4 and b is 6. Now, we're going to need to convert our c squared into c, so we're going to need to take the square root. And to do this here, we actually have two variables, whereas before with our previous Lambda, we only had one variable. We just had y. So to do this, we are going to need to specify our formula just like we did here with c, but we recognize that we're going to have a and b as variables. So pause the video, see if you can come up with how to do this. Can you solve for c? And then we can put in what if a is 2 and b is 3, what if a is 4 and b is 6. All right, so hopefully you've had a chance to try this. So we specify that c, and we'll call this C2. C2 is equal to lambda AB. There's two variables, A and B. And we need to give our formula, which is going to be A squared. So how do we do squared? It's 2 stars, remember? A squared plus, and then we have B squared. So 2 stars for that. Okay. So this is just like we did before. And then notice once we run that, before all we did is then say, okay, well, the output, we just put in parentheses what the value of those variables are. So let's do that. Let's run this. Okay, so then we say, okay, C2, and the value of A is 2, and the value of B is 3. So C squared is 13. We want to know C, so we're going to need to use the function math.sqrt, and we're going to need to import the package math in order to do this. So we're going to import math. And then we are going to use our function math.sqrt. And let's see, can I do this here? So what we get by putting it all together into one, math.sqrt, and then around that C223, is that the length of C in our triangle is going to be 3.6 if A equals 2 and B equals 3. That means that if we want to find out what if A equals 4 and B equals 6, all we have to do is trade out the 2 for a 4. And the B was a 3, and now it is a 6. So 4, 6. And so if A is 4 and B is 6, then the third side of the triangle is 7.2.